Well, hello, friends. Today we're going to work on the sound system of Serenity, and it's going to be about having a mute-unmute thingy where we can like enable and disable the sound globally in the system, I guess. And I imagine that we would put this as some kind of an icon up here. Maybe maybe to the left of the CPU graph, maybe to the right. Let's put it to the left. So, not exactly sure what this is going to look like, but maybe we can just start with, let's see, we have some icons. But the basic idea is that you're gonna click on this thing to turn off the sound, and you can click on it to turn on the sound. So we have this little icon here. Maybe we can do something with that. Could make a variant of it. Although how tall is the menu bar? Menu bar rect. Menu bar rect is 18 pixels tall. So it's what was it? File type sound. That's the one. So that's like 16 by 16, right? So we can probably fit that in up there, and then we can make a silent version of it. Maybe we'll make it look a little different also. Maybe it would be all black. I don't know. We'll see. But the first thing is that we're going to need because the menu is managed by the Windows server process. We are going to need Windows Server to talk to the audio server just to figure out what's the current state. And also, there's no like muted or unmuted state. We're going to have to add that. So let's do the muted unmuted state first. So we'll go into audio server IPC protocol definition here, and we'll say set muted. I guess it'll just be something like this. Muted bool, and it will be a synchronous message that returns nothing. And we can also have get muted, which will return a bool muted. It's been a while since I've been using this. So this is a custom IPC protocol definition stuff that I made a while back. So let's see how we would implement these. So the thing is that when we put this stuff here, then we run the build scripts, then these things will be added as messages that we can instantiate. And what did I mess up here? I have to name this thing. Bool muted. Right, yeah, because it got a little cranky there. Okay, so now it doesn't compile anymore because we have to instantiate these get muted and set muted things. So we have to look for someone who inherits the audio server endpoint, which is here, the AS client connection. So the way that we implement these is that we override the get muted handler and the set muted handler. So they're both called handle, and they get this kind of object passed to them, and it has to return a response object. And then it's going to be in the audio server, there's this object called the AS mixer, which is like the big mother object in that program, and we're going to have a muted state, which will be false by default. And then we'll say like bool is muted, const return m muted. set muted, and I guess really when we set muted, then we need to, what do we need to do? We need to stop mixing audio immediately, because right now in Serenity, all the sound stuff is software. We do all the mixing in software, and then we just send the mixed audio to the sound card. So we don't use the sound card's own mixing controls. So right now, we're not going to use those and like mute the actual mixer of the sound card. Instead, we're just going to like stop sending data to the sound card. But in the future, this should probably be enhanced to be aware of sound card features like mixing. Anyway, we are still in very early stages here, so let's see. I guess when we're mixing together, this is the main loop of the mixer. It runs on its own thread, and where is the code that mixes? So I guess when we're muted, we still want to process the incoming stuff, and we want to progress any sound playback that's happening. We just don't want to hear it, right? So I think here is where we write the bytes to the sound device. So I think we can just, the lazy version here is to just check if not and muted, then write it to the device. Okay, and then in AS client connection, we got to implement those IPC calls. So first we had audio server get muted response, and gets one of these. And it's going to be, we return audio server get muted response. Mixer is muted. So that's how you implement one of those IPC APIs. The other one was set muted, so that would be set muted response. And in this case, we have to actually look at the contents of the message. So that would be mixer set muted message dot muted. And oh, set muted, I forgot to take an argument. Yep. Okay, and then we just return, just return an empty response here. Like that. It's pretty neat. It still needs a lot of work, the IPC stuff, but I'm already pretty happy with, I mean, at least I'm happy with this way, the way that you use it. I'm not super happy with the code generator or the code that it generates, but but usage-wise, it's pretty cool. So we need to implement set muted. So an AS mixer. Let's see. Maybe it's just a matter of setting that Boolean. Maybe it's not. Maybe we don't have to do anything more than that at the moment. So I was thinking we could like accelerate the stopping of the writing to the device somehow. It should not be const. Okay, I think maybe we'll just leave it like that. That'd be pretty good. And we should probably have a little test program to use this functionality. So we already have a test program for changing the volume. It's called avol. So with avol, you're just setting the mix volume. So a client connection is the class that connects to the audio server. So let's add an API to it. Get muted. I don't know, something like that. And void set muted. And then the way that you implement these is that you get muted, just return send sync audio server get muted. And you get the, so this is not going to return until the other side has responded. And then you can just get the variable that you wanted from that. So here's the generated code. You get a get muted response, which contains the muted field generated from this thing right here. So this is the get muted response. I really quite like it. Anyways, that's enough fawning over my own code. Set muted, boom, muted, and then the same story here. Set muted, except now we have to pass the parameter, and actually we don't actually care about the response in this case because it's empty. We just made it synchronous because then we don't continue what we're doing until the audio server has confirmed that he did indeed mute. So maybe we can put this as something in eval. In the eval program, we can do if RHC, let's see, if RHB 1 is, I don't know, I'm just going to be a little lazy here. I always do lazy things with arguments parsing. This will be to mute, I guess. I will do audio client set muted true. Turn null. Printf muted. And we'll do this big M for false. Unmuted. All right. Yeah. And let's see if this works. So eval-m will mute, eval-M will unmute. And I do have some wave file here. This is a Windows startup sound, and this is a song that I posted a while ago. So I guess we'll play that. And then eval-m. Boom, look at that. It's pretty neat. Let's bring the sound back. Oh. Oh. It did come back. So it takes quite some time to become unmuted. I wonder why that is. Oh, I guess that's because like the CPU usage just spikes when we're not writing. Because I think that normally what happens is that this will block, and it will block until we've finished playing as many samples as are in here. And when we don't block, then we're just progressing like crazy through the sound. So actually, let me see if the sample, I forgot to look at the sample count. So we can see the progress. Well, it doesn't seem to go like that much faster. I don't know. But maybe this is not the best solution then, because we're kind of relying on the sound card to do the timing for us. And now if you stop writing to it, then it won't block, which means that we're not going to get the... Because it only plays back as many samples as we give it, the sound card, I mean. And when it runs out of samples to play, we find out, and then we queue some more samples, and time is kept. So instead of this, maybe we can just send zeros. Then the timing will still be intact. And it's a really cheesy solution, but I think maybe that would be okay for now. So if M muted, instead of sending the buffer, which is really just this buffer right here, this will be really cheesy, but this is so weird. Oh, M device. Oh, wait, hold on. Let's always write the buffer, but if M muted is true, then we'll do a we can just not populate the buffer at all. So if not muted, and if not muted, okay, let's do if muted first. So if muted, then memset raw buffer 0 size of raw buffer. Okay, let's try that out. So now instead of not sending anything to the sound card, we'll send 0 filled buffers every time. It seems silly to do the memset every time. Actually, that's so dumb. So let's just have a special page for that we can set aside. So maybe we'll have a special one that we just create here. Or it can be a member, it doesn't matter. U8 M0 filled buffer. Zero filled buffer. Something like that. Do I have B0? I do. Yeah. Well, whatever. That's okay. And then we will if M muted M device write 0 filled buffer. Oh, buffer is just a wrapper. It's a wrapper that we make up here. So M muted. Since this is threaded, let's actually do this. A little lazy protection there. So if not muted, then we mix, and here we create. So this is just a wrapper buffer that we're making because this API down here takes a byte buffer. So we have to make a buffer around this stack allocated buffer. If muted, then M0 filled buffer, otherwise M the raw buffer. Okay. All right, so let's say play. Boom. This definitely bumps up the CPU usage. What is it doing? Show me the system monitor, bro. Oh, it's so slow. I mean, it's gonna be play is using all the CPU. So this program, what is it even doing? Show me your stack, bro. He's queuing data for the other side, right? So why is that happening? Because now we're writing the stuff. The zero fill buffer. If not muted. So we're not muted, so we're not doing this. Stream offset. Oh, right. Stream offset. Okay, so I guess here we got so device is wait, what am I trying to do here? We always want to write to the device, right? True. Write to device. If stream offset, else if not muted. Why would we be down here? I don't understand. If there's anything to write, then we'll be down here. Okay, so we should always just write. I don't know how I'm trying to read this code. Because the stream, in this case, that's this buffer stream, which we're using to mix samples from each queued up sample buffer that we have currently pending in the mixer queue. So okay, finally we have some more reasonable behavior. I mean, it's still hogging that CPU, but it's not completely choking the system, at least. Still very, very intense. I wonder why. So much of it is just sleep. Why are you sleeping intensely, dude? How does that even work? I guess because it has more than one thread, I was gonna say, but it doesn't. Weird. Oh, it's doing something. Anyways, so, oh shit, I forgot to actually test unmuting. Okay, so it totally works. I'm assuming that you can hear the music coming from the speakers, by the way, otherwise this video doesn't make any sense. Okay, so we have a feature. That's cool. So let's just browse through it right quick. Get muted, set muted, blah, blah, blah. Implementing and so on. Then passing a bunch of zeros to the sound card if we are muted. Cheesy, but it works. And then adding the AVOL thing. All right. So, audio server. Allow muting the system audio. This patch adds muting to AS Mixer, which works by substituting. We would normally send to the sound card with 0 filled memory instead. Do it this way to ensure that the queued sample first keep getting played, since we want keep getting played silently. This is obviously not the perfect way of doing this, and in the future we should improve on this, and also find to utilize any hardware mixing functions in sound card. Okay. And you know, we should write a man page for the AVOL change. So hold on. We should. That's the right thing to do. Let's be good boys. So this goes in man 1, I guess. We don't have a man page for it, so we'll write a new one. AVOL ND. So man pages in Serenity are all in Markdown, which is very, very cool, I think. It's Sergey started this a while ago, and it's really, really sweet. So I'm just going to copy the format he's been using here. So change system sound volume. AVOL options. We'll say like M or M. Or volume. M. Mute system. Mute all audio. Right. AVOL 100. I don't really know what that number even represents. It's not super clear. What happens when you call set volume? Set mix volume? Mix? There's some mix volume something. Main mix volume. Right. And then what do we actually do with that in the audio server? Main mix volume. We call set main volume on the mixer, which sets this thing, which we then use to scale each sample as we are mixing them together. And it's an input percentage. So a volume of 100 is samples are played verbatim. And I guess that's how that works. So it's almost like an amplifier. not really it's not like a limiting volume thing, or I don't know the terminology for this stuff, but anyways, we are just gonna we're just making a man page. So this program is used to control the audio server, volume and mute state. And I guess, what would you say, like options? It's not an option really, like it's more like a number. So it's a little bit of a weird syntax, but I'm not here to fix the syntax right now. So what happens if you run it like this? Aval 100, volume 100, right? So let's see, we can write something like set the volume to 100, get the current volume, it's just aval, and it should say volume like 80, for instance, mute all audio, and unmute all audio, and like that. Okay, and let's just see how that turned out if we look at the man page in the system. Man aval. That's pretty nice. Let's open it in the help. Aval. Should make these alphabetized. Didn't I put spaces between those? Oh, it doesn't care about the empty lines here? That's so weird. Not VI. Well, I mean, I do have Vim, I think. We can use Vim this one time. Come on, Vim. Oh, dude, Vim needs help. All right, never mind. We're gonna use text editor and stuff. I need some work on that Vim port. Unable to save file. Oh shit, because it's owned by root. Do we have save as? We do. Okay, we'll save that in our home page. Not home page, home directory. And then we will use the md command to turn that markdown into HTML. And then we will pass it to the HTML command to render it in a thing, and that totally did not work. Why did that not work? I have no idea. That worked. So HTML was not super interested in reading from standard in anymore. Must have broken that at some point. But I see that we don't care about the new lines there, so it's probably a bug in libHTML. Anyways, we're not here to work on that. I just wanted to make a man page, and this man page is probably not perfect, but it is at least a man page. So I've been a slightly good boy. Aval 1. Okay. So let's see about adding the volume control to Windows Server. So, or the mute control rather. So in the menu manager, where do we draw the menu bar? We have a draw function in the menu manager. And this function here is responsible for drawing this thing up here. So this thing up here is in a window of its own. It's this object here, and window, in the window manager, menu manager class. And the draw function will imperatively draw the whole menu bar, starting with the individual menus from the left, and then over on the right we do the CPU usage graph here, and we do the username and current timestamp or current time. So I think we're gonna, the CPU monitor is gonna be to the right of the volume control maybe. So we'll put it to the left of it. So then say volume or audio rect maybe. Call it sound, studio audio rect. It's going to be the CPU rect dot left minus 18 pixels. Let's say 20. And the y coordinate, I guess the CPU rect y coordinate. And the width is going to be 16, and the height's going to be 16. And let's just draw something there. So first thing is we're going to need some bitmaps here. So ref footer to graphics bitmap, m muted bitmap, and unmuted bitmap, and then we will, I think we'll just load those. So let's for now we can just use two random icons. So m unmuted bitmap is graphics bitmap load from file res icon 16 by 16, file type sound. That's this one. This one is okay, but we need a muted version of it too. So for this, we'll just use something silly right now, like the HTML file type. And then let's see, where do we draw? The audio rect. So painter lit at the audio rect dot location. The m unmuted bitmap and the m unmuted bitmap rect. The opacity is just going to be, oh, oops. Opacity will just be the 1, so we draw it at 100% opacity. And maybe we should make some cooler versions of these. Come on, GIMP, open up. So I was thinking like maybe we could do this. It's kind of nice. Save, export as, I guess, and this will just be sound muted. No, unmuted. Audio unmuted. I don't know. I'm just picking the very specific PNG settings for some reason. And then we'll also have this version of it for the muted state. Okay, and we can pick those up right away instead. Audio unmuted and audio muted. Although maybe it looked awesome with the old one, so I'm just going to see. So that's what it's like right now. It does actually look kind of good with the color, I have to say. Maybe it would look kind of lame with the monochrome. It's very very old Mac OS. Oh man. I like this one, but I also like the other one. Ugh, tricksy. Let's go with this one, because, I mean, actually, let's go with the other one. Let's be a little more colorful. We can afford it. So let's save this one as audio unmuted. And then we'll make a version of it. And then we can even do a little bit of desaturation here. Just a little bit for the muted version. Just for flavor. No big deal. All right. Now let's make something happen when you click on this good boy. So I assume we have some mouse event thing here. Yeah, menu manager event. If we get a mouse down, then we try to pin it on one of the menu bar menus. But if it doesn't hit any of them, then we don't do anything. So no, that's just because nothing else in the menu bar is clickable so far. It just sits there. So I think we are gonna say if mouse, or rather if event type is mouse down and event position. Oh, we don't. Oh, it's casted. So mouse event position. We're gonna say like the audio rect contains if it's a mouse down. I mean, we can do it this way actually. Mouse event type is mouse down. Oh, there's no audio rect. Right. Yeah. That's not a function. Oh crap, it's kind of tricky to compute that actually, because it's based on the CPU rect, which is based on the time rect, which is based on the username rect, which is based on the width of the username. Well, isn't that convenient? So I think here we're just going to be a little bit lazy, and we'll just do this. Oh wait, what the heck am I doing? Like this. We're going to store it in a member the first time that it's done like that. M audio rect. And we'll say fix me. This should only be computed once. So rect should only be computed once. Same with this one. Same with this one. And same with this one. Okay, it's a lot of fix me's. Okay, so then we will have M audio rect available to us here. And we can check if the audio rect contains the mouse event, and it is a mouse down. I guess we should also check mouse event button is WS, what is it, mouse button left? Yeah. If this is all true, then we are clicking on it. So I think at that point we'll do something like M audio muted is M audio muted. We'll just do something like this to try it out. And we'll also have to invalidate our window so that it gets repainted. I'll have to redraw as well. So this will be a little bit, it's going to do a little bit of extra painting work than you might not need to do all of that repaint. You don't have to repaint the whole thing, but we will, because that's how this thing works at the moment. So what was the thing that we added? M audio muted false. And then my thinking was, in the draw function, we would just look at that audio muted thingy and pick the bitmap based on that. So audio bitmap is audio muted, M muted bitmap. Otherwise, M unmuted bitmap. Right. Okie dokie. So, if this all works, then it should be clickable, and clicking on it should just change the icon. Between this and the other one. Could probably desaturate a little bit more here, actually. That looks pretty cool. It's a little bit weird how far off from this thing it is. Let's see what we can do about that. Maybe this thing doesn't need to be 16 by 16. Could easily be 12. Hold on. We'll duplicate this layer and then we'll go. Wait. What am I trying to do here? Come back to me. Okay, so we have this, and then we'll go backwards until it looks normal, and then we'll paste as a. No, not like that. How do you paste this new layer? Control Alt V to new layer. Right. Dimmy unmuted. And then we will just make this smaller like this. So crop and should we do it this way? Looks a little bit weird. I don't know what I think about this. Should we make this even bigger? Oh, that's the wrong direction. What am I even trying to do here? Like, go away, Dimmy. Is this too much? And then we take another layer of this. I wonder if it is too much. I'm not sure. It does feel a bit much. This is pretty good, but maybe we should. I don't want to move it because like you could imagine like moving this thing to the middle when you undim, right? Or when you unmute, mute, unmute. Would that look good? Maybe it would look good. So now we have 3 pixels on that side and 4 on that side. I don't love that. But it is better, so maybe we'll try that. And we'll try it. Okay, so this will be audio unmuted. And probably it shouldn't be in 16 by 16 anymore. So we'll just put it in icons directly. And Then we'll do this one, and let's actually desaturate to that point. Yeah. All right, so now they're 12 by 16. And they're not in 16 by 16 anymore. Okay. You gotta get these little details, you know, you gotta get them to feel right. Otherwise, it's not gonna be pleasant to sit here and use this. And I don't like that it moves. It looks crappy. Yeah, it was better when it didn't move. Dang it. All right. But it is okay that it is. The desaturation was also not needed, actually. So that's where it was sitting, right? Yeah. I think we can probably live with it like this for now, and we can revisit this icon in the future. But it's the distance from the unmuted icon, from the muted version to the CPU graph. It feels this is quite a long distance here. But it's okay. It's okay for now. Maybe if we had some kind of a divider of some type, it would look a little more natural, but it's still okay. All right, so let's make that actually change the sound. So right now we're just building this into the menu manager. It's probably not the perfect design, right? But it's okay. Later on, maybe we should have an architecture for apps embedding themselves into the system tray or something like that. But right now, it's just going to go in here. So we'll make a client connection. Oh, actually, that has to be in. We need an object to store that. A client connection. What does that look like? We can put it in an own pointer. I guess audio client. Okay, and then we'll just say audio client is make a client connection. It's a bit of a strange name for this object. Maybe if I renamed it, I would call it something like audio client or audio server connection. I don't know. It's not the most important thing. Far from it. So now we have this, and what can we call? We can call these synchronous functions on it, right? So we can call set muted and yeah, let's set muted first. So audio muted. Let's see, audio muted. We don't have a way to get this from the audio server at the moment. I mean, we can query it, but we don't have it's not going to broadcast it to us, and we don't have a mechanism for that at the moment. So, and that's a bit too big of a change to start making. So we're probably going to have to hack this a little bit. But when you click on this guy, we can do audio client set muted. Audio muted. All right. And I think hopefully that would just work. Hopefully. I'm not sure though. So I've never tried to connect the Windows server to the audio server before, so I don't know what we're getting ourselves into here. We'll now link this against libaudio. And that had troubles because we also need libipc. It linked. let's see if it runs. Okay. Well, I guess. It totally works. That's pretty cool. So something that's a bit sad now is that if I change the sound volume here, right, if I do like AVOL-M, it's now unmuted, but it doesn't show here because the Windows server has no way of finding out that it became unmuted. So it's not perfect. We should learn that from the audio server somehow once that broadcast information mechanism is in place. So fix me. Listen for notifications from the audio server once those actually exist. Right now, we won't notice if another program changes the audio server muted state. Okay, well, still, it's pretty cool though. So let's remove those two first 16 by 16 attempts there. And we'll add these with the change. And we'll say boom-be-doom. Windows server. Add an audio mute, unmute icon to the menu bar. Audio icon. Right now, it shows the current clicking on this icon toggles the audio server muted state. It's currently does not react to muted state changes caused by other programs, since it has no way of learning about those from audio server other than performing a synchronous IPC call to get muted, which we don't want to be doing in the Windows server. That's pretty cool. It's pretty freaking cool. All right, so obviously this can do, we could make it do so much more. We should probably have it able to change the volume. Maybe we could have this different variants of the icon with like more and more sound, less and less, depending on how you change the volume. But it is pretty cool, just the way that it is. So I'm happy with that. Let's play the Windows sound. Oh, nice. All right, so I think this is going to be it for today's video. So if you made it this far, then I thank you for watching, and I hope you saw something interesting. And I will see you next time. Bye.